The complement is what makes up the whole. Okay, now with words, that's easy. Okay, when I asked you guilty, you said not guilty. All right, so that's easy. But what about when it's numbers? When it's numbers, you've got to remember what the whole is. All right, what is the whole? Well, if you have 250 workers at a company, the whole is 250. Okay? If you have 5,000 employees, then the whole is 5,000. In probability, the whole is usually 1. Okay, write that down. In probability, meaning the decimals, the whole, a W-H-O-L-E, the whole is usually 1. Okay, now there's extenuating circumstances if I can find my dadgum mouse. Okay. I like to be able to see what's going on. Let me put on, I'm talking to myself. There we go. I wish they had this camera up a little bit. Like right there. I look like Johnny Green Giant. All right. So, what is sometimes you're going to be given a whole of, and this lights are not right. Sometimes you're going to be given a whole of 250 people. Okay, then what is the complement? Well, whatever they give you. So they're going to give you a problem, and they're going to say, there, that's better. They're going to say 250 employees work at a company, and 100 are sick. How many are not sick? That means I want y'all to answer.
Oh, 150.
150. So 150 is a complement to 100. 150 make up the whole. If I give you 1,000 students at a college and 200 are in the Marlboro Club, that means how many do not smoke? 800 are not in the Marlboro Club. Now, a lot of times you're going to see a teacher put sick and then put an X through it. That means the complement. All right? Whatever they give you is the total. They're going to give you the total, and they're going to give you how many are blank. And then you say, well, how many are not blank? That's one of the first things you said. This is usually called a ratio, poor old Horatio. Okay, this is usually going to be where you have a ratio. A ratio. Other than a ratio, most of the time in probability, your whole is going to be 1. Well, what is the highest number probability can go up to? 1. Since 0 to 1 is probability, a lot of the time, if you're not given a ratio, not given a total / ratio, your number will be what? 1. So let's say that I give you let's say that I say, if I give you a question and I say, 65% of the population is blue, then how many are not blue? I'm asking y'all a question. It's not rhetorical. That means I want y'all to interact with me.
Can you say that one more time? I was writing.
Something. Either I don't know, or I don't have a clue, or I'm just being quiet.
Can you restate the question?
65%?
I said, if 65% of the population is blue, how many of the population are not blue?
35%?
35.
Good, because 35 is the complement to 65 to 100%. What if I said 0.25 probability of picking a queen in a deck of cards? What is the probability of not picking a queen?
0.75.
0.75. Okay, so the complement is whatever makes up the whole being one of two things. Either it's going to be a total, like 250 employees, or it's going to be a probability, which means a percentage or a decimal. Capiche?
Yes.
Okay. So that's very important because a lot of questions in this class in 120, and I encourage you to take 120 next semester if you haven't, because these first 2 units that you're doing right now are the first 2 units in probability. So make sure you take the 120 class when I teach it, because that's why I do these. So anyway, I'll shut up. So there's the, let me erase this. There we go. All right, since the probability of 3 children of having 2 boys is 0.375, what is the probability of the complement? So what would that be? They're giving you a decimal, so you've got to find the complement of that decimal. Point what? 625? Somebody take 1 minus 0.375. Now, easily, I only see. Well, I'm gonna have to re-put this on there because I only see Miss Riddle and half of Miss Carver. Right? Is it Miss Carver?
Carver.
Sorry, Carver.
It's 65.
So I've got it there. Now I can see all of y'all. Okay. I need to get rid of this one. I wonder if I can get rid of this one. I bet I can. No, I can't. I know y'all have no idea what I'm talking about, but on my screen I can see only Miss Riddle and Miss Carr. And what's the other one's name on that side of the room?
Morgan.
Miss Morgan. Is that Miss Morgan? That's not your last name.
Yes, it is.
Okay, Miss Morgan. I only see Miss Riddle, half of Miss Carr, and half of Miss Morgan. So that's why I'm talking to myself. Now I can see the whole side. I'll shut up. Anyway, 0.625 is what I get.
Yeah,
Let's see what happens. Look at there. It's a miracle. So the complement of 0.375 is 0.625. Now, a lot of you are saying, well, Hubert, why doesn't it say complement on the slide? Because this book sucks. That's why. Okay? Anytime you walk into a statistics course, anytime, they're going to talk about the complement. And that is what the complement is. The complement is what makes up the whole. What's the complement of man? Woman. What's the complement of true? False. What's the complement of 0.25? 0.75. What's the complement of 250 if 100 are sick? 150 are not sick. Okay? So you've got to be able to think in that realm of not. Okay? Or the opposite. Or what makes up the whole. A probability distribution. A probability distribution is this right here. It's basically the sample space. All right? Read this question because this is a predominant standardized test question as well as a regular test question. Okay? Make probability distribution for the sum of the dice when 2 fair dice are rolled together. What is the probability? What is the most probable sum? In other words, which one shows up the most? Okay? So you go through and you think of rolling that die. Well, I can get 2 1s. I can get a 1 and a 2. I can get a 1 and 3. I can get a 1 and 4. And I can get a 1 and 5 and a 1 and 6. And then I can get a 2 and a 1 and 2 and a 2, 2 and a 3, 2 and a 4, 2 and a 5. And you write all that out. That is called a probability distribution. Or it's called a sample space. In other words, what are the possible what? Outcomes. Now, as you can see, where is the number 6? Well, there's 1, 2, 3, 4, 5. There's 5 rows that will give you a 6. And then check to see if there's any other. 1, 2, 3, 4, 5, 6. I see 7. 7 looks like to me it's more prominent. Okay? I may be wrong, but somebody look at it and see. 1, 2, 3, 4, 5, 6. There's 6 7s. 1, 2, 3, 4, 5, and 5 8s. So it looks like to me 7 is the one that comes out the most, but they keep saying prominent. There are 6 ways for each die to land, so there are 6 times. Oh, okay. They're saying they're explaining the sample space. Okay, but what is the most probable sum? Well, it looks like to me 7 is the most probable sum. Why? Because it shows up what? 1, 2, 3, 4, 5, 6. The rest of them show up less. Most probable means what? The one that shows up the most. And there is your probability distribution right there. Now write that down. How many times did 2 show up? Well, 1 out of 36. How many times did 3 show up? 2 out of 36. How many times did 4 show up? And so on. Now make sure you understand. Now, as I said before, once you start doing this right here, once you start saying, okay, 1 plus 1, 1 plus 2, 1 plus 3, all right, then turn 1 die. Okay, 1 die you turn to 2. Then be 2 plus 1, 2 plus 2. You change that die to a 3. 3 plus 1, 3 plus 2, 3 plus 3. Change it to a 4. 4 plus 1, 4 plus 2, and so on. That's how you do the sample space for the 2 die distribution. This is, like I said, it'd probably behoove you to write this down and keep it on an index card so you can actually get to it quick on a test, because that's like I say, that question is on just about every test that there is. And then you take the totals. Okay, how many times do you get a 2? There's 1 time you get a 2. I don't see any other 2s. So 2 would be 1 out of 36.
Okay.
How many times you get a 3? 2, that'd be 2 out of 36. How many times you get a 4? 1, 2, 3. 3 out of 36. And so on. And that's what they're doing on the next page. And of course, you see the normal curve. Goes up in the middle and comes back down. Good question there. Odds. This is what you get paid out on, and this is what we're going to spend today on, because this is, and I'm not worried about for, I'm worried about against. Make sure you highlight against. Now, I don't put it in this way because this, to me, is confusing. So I put the probability of failure over the probability of success. That's what I do. Probability of failure over the probability of success. And I also tell you, when you're doing odds, make sure you leave your numbers as what? Fractions. Why? Because they're easier to work with. Actually, fractions are the easiest to work with besides whole numbers. But they don't teach you that in school, so you can depend on that calculator so you don't have any critical thinking skills when you get out. Okay? So, what is the probability of failure? Whatever they're not asking for. If I ask you to pick a king out of a deck of cards, what is failure?
Anything other than a king.
Anything other than a king. Then what is success?
A king.
Okay, so make sure you understand that. All right? If I ask you picking a heart out of a deck of cards, then you say, okay, success would be picking a heart. Failure would be not picking a heart. You've got to understand the reasoning behind this. If you don't understand it now, you're not going to understand it when we get into the other stuff. Okay? So make sure you understand success and failure now. If I tell you what is the probability of picking an even card, then that's the probability of success. If I tell you if the probability of even is what we want, then the probability of not even is equal to the probability of failure. Failure is the complement of success. So therefore, whatever number you get for success, the other number, the complement, is going to be the failure. Okay? Usually they give you the roulette wheel on this one, and we're going to do a roulette wheel question. So you'll have it for your notes. Okay? What are the odds for getting 2 heads in a tossing 2 coins? What are the odds against it? The odds against is the reciprocal of the odds in favor. I don't like to do the odds in favor because that's not generally what you're asked on a test. Usually you're asked the odds against because that's what Vegas and that's what the gambling industry pay off on, odds against. Okay? So here is the probability of 2 heads, 1 out of 4. And we talked about this. This was like the 2 babies. Okay? You had to have 2 girls or 2 boys, or 1 girl, 1 boy, or 1 boy, 1 girl. That's what this is. All right? Now, so they just botched this up. I'm going to the white screen. They just botched this up because no wonder people can't understand. Hold on a second. Let's go to the whiteboard. Let me pull up a roulette wheel because we're going to do this the right way. If I'm going to do it, might as well do it right. And not botch it up like they just did. So, for those of you that do not know what a roulette wheel is, this is what you're going to see on a standardized test. They love to do roulette wheels. Let's see if I can get a good one that's blown up. Okay, looks like that one's pretty good. Maybe we can see it. I hate when they do that. Damn Russians. Okay, here's one. Yeah, make it a little bit louder, so I can really hear it.
Okay.
Y'all do know that's not proper etiquette. Y'all do know that, don't you? Okay.
Yeah.
Okay, just wanted to know if you knew that. All right, so I take my handy-dandy whiteboard, and I'm going to pull in that picture. No, I hit the wrong one. Sorry, hold on a second. I knew I should have spent more time on poster training. It's not going to let me pull that picture. Why not? Insert image. Download. Oh, there it is. I must hit the wrong button. All right. Now I want y'all to count the highest number on this roulette wheel, because I have no idea. I just pulled it off the internet, so I have no idea. I see 34.
I see 35.
35.
36.
Yeah, it has to be even, yeah. 36. You see 36? Anybody see a 37? I ain't found 36 yet. There
It's
it
on
is.
the bottom right
Okay, I
now.
see it. 36 is right at 4 o'clock. All
That's
right,
the highest number.
I think 36 is it, isn't it?
Yes.
Okay. Now the question will read something like this. Dang old. Tri-County Tech, they talked about it yesterday. They're trying to figure out why the online classes suck at Tri-County Tech, why there's such a big failure rate of online classes at Tri-County Tech. I wonder if it's anything to do with you got teachers that don't know how to use PowerPoint, email, and YouTube. Reckon it has anything to do with that? Anyway, shut up, Hubert. I'm going to put roulette. I don't know how to spell roulette wheel. Roulette wheel as I'm ad-libbing. I'm not properly doing this. Slots numbered from 1 to, what'd you say, 36? And 0 and 00. Parentheses, 0 and 00 are neither, however you say it, and I hope I spelled it right, I don't know, odd or even. What is the probability of an even number? That's A. What is the probability of the marble falling on an even number? I'm not writing every single word. My typing skills are not that good. Okay. What is the probability of an even number? A. B. What are the odds against, and I use against most of the time on my questions, of an even number? And C, what is the payoff with a $500 bet? So this is the question you would see with this roulette wheel. All right, the first thing you have to do is find out what is the probability of an even number. Well, that's easy. 1 to 36 divided by 2, 36 divided by 2 is what?
18.
18. So there's 18 even numbers. So the probability of an even number is 1 out of what? Is 18 out of what?
36.
38. The probability of an even number is 18 out of 38. Why 38? You said numbers 1 through 36. How does the roulette wheel work? Somebody tell me.
No idea.
You're kidding, right? You've never seen a movie with the roulette wheel in it? Gambling?
I guess you spin it.
You spin it, yes. You spin it one way. And what's the object of the game? There's a marble that spins the other way on the outer rim. You got two wheels basically going in opposite direction. Well, what happens? Gravity is eventually going to pull the marble down. And where the marble hits, that's the winner. Everybody with me?
Yes.
Okay, so how many slots are there on the roulette wheel?
$38.
38. Tell me what they are, whoever answered that.
0 through 36.
Well, 1 through 36, that's 36. And then what?
0.
The two greens, which is 0 and double 0. Now this one does not have a double 0 on it. I don't know why. Most of them do have a double 0. Okay? So, just make that note. There's supposed to be another double 0 on here. I don't know why. But anyway, so there's 18 even numbers between 0 and 36. But on the bottom, 1 through 36 is equal to 36 slots plus 0 and what? Double 0 is equal to 38. So, even is success, right? What is failure? Well, that would be the probability of not even. And that's going to be what? 20 over what? 38. Where'd I get the 20 from? 20 is the what of 18?
Complement.
20 is the complement. Now, a lot of you are saying, well, wait a minute. No, you remember I told you, you get the complement. All right? The complement of failure is success. The complement of success is failure. The complement of 18 to 38 is what? 20. And then, of course, 38 is the total number of slots. I'm not going to use this right here. Okay? So now you have the two probabilities. So you've got the probability of an even number. You've done that. That's 18 over 38. Now I want you to follow the rule of odds against, and put the probability of failure over the probability of success. And leave it in fraction terms. So this is A. B is going to be 20 over 38 divided by 18 over 38. Now do it. Because basically, you don't divide by a fraction. What do? You multiply by the what? Starts with a R.
Reciprocal.
Reciprocal, yes. So I'm not going to divide by 18 over 38. I'm going to multiply by 38 over what?
20. Or 18.
18. So I'm going to multiply by 38 over 18. Well, what happens to the 38s?
They cancel out?
Will that happen every single time? Yes. That's why you use fractions. And now I've got 20 over 38, or 20 over 18, and what can I reduce that down to? Well, I know 2, we're going to have 10 over what, 9?
Yes.
Or 10 to 9, or 10 to 9. That's the 3 ways to write the odds against. Now, if the odds against are 10 to 9, what's the odds in favor? 9 to 10. Just the reciprocal. So make sure you write that down. The odds in favor would be 9 over 10. The odds in favor is the reciprocal of the odds against, and vice versa. So if they ask you for the odds in favor, then you would say 9 over 10, or 9 to 10, or 9 colon, semicolon 10. But I usually, on my test, I just ask for the odds against. So how do you do the $500 bet? Well, I'm going to go to a separate page, and we're going to talk about something before we talk about that C. Okay? And I'm going to do it because this is the way I teach it. If I could remember how to work the board. looking at those posters yesterday sent me back into, retro. So I losing a little bit of steps on my board here because I've been posterized. All right. So let's say that I got a recipe that makes 24 cookies. Okay? And that's 2 cups of milk, 3 cups of flour. I'm just making this up, so I don't need anybody going, well, really, you need to have them. Shut up. 1 cup of sugar, 1 stick of butter, and 1 tablespoon of vanilla. Okay, I'm just making stuff up. All right. Let's say I want to make 48 cookies. What I do, I want to make double that amount. Well, I double everything. How do you get the word double? You multiply everything by 2. Well, how do you get that? Well, 48 divided by 2, 24 is equal to what? 2. So this is a multiplier, 48 over 24. That's really what you're multiplying by, which is 2. All right, so that means I get 4 cups of milk and 6 cups of flour and 2 cups of sugar and 2 sticks of butter, whatever, and 2 tablespoons of vanilla. Okay? What if I wanted to make 72 cookies? If I wanted to make 72 cookies, that would be 72 over 24, which is what? 3, and I would multiply everything by what?
3.
3. Well, what if I wanted to make 102 cookies? Well, 24 will not go into 102. So that's going to give you a fraction. 102 divided by 24. Well, 2, that'd be 51 over 12. So I would multiply. Somebody do that in your calculator. What is 51 divided by 12?
4.25.
4.25. So I would multiply all my ingredients by what? 4.25, or multiply them by this multiplier right here. Everybody with me?
Yes.
Okay. Y'all are gonna have to talk. I mean, this is a little bit ridiculous. One person out of 6 people talks. Well, Coney left. Okay. So I assume, Miss Riddle, you understand what's going on because you're the only one talking.
Yes.
Okay? So, fine, I'll just go faster. Nobody's going to talk, I'll just go fast. All right, so let's go back to our original problem right here. So what is our multiplier? Our multiplier is what?
10 over 9.
10 over 9. So somebody give me a decimal. What is 10 over 9?
1.10, I think.
So I think it's 1.1 repeating.
Okay.
Somebody check me.
It is. Yes.
Okay, 1, 1, 1, 1, 1. Okay, so that's my multiplier. So what is my cup of sugar? $500. So C is going to be $500 times 10 over 9, or $500 times 1.1111 repeating. And somebody tell me what that number is. going to be $550 or something like that. What is it?
$555, 0.5 repeating.
So how much did I win?
$55.
I won $55.55. Why didn't I win a lot of money? Somebody tell me why. What I tell you before about the probability, and that I don't know if I told y'all this or
If
not.
the chance is less, then it's going to have a higher payout.
Exactly.
If it has
Is the probability high or low here? Somebody take 18 and divide by 38. What do you get? What's 18 divided by 38? Point what?
47. 0.47.
Basically, you've got a 50% chance of winning. What does Vegas say about a 50% chance of winning? What does Vegas say? That sucks. So I'm not going to pay out a lot on a 50% chance of winning. Why? Would Vegas be what it is today if they paid out on 50%?
No.
They'd be bankrupt. Okay? So, what changes things? Well, let's delete this whole board, and let's change. Will this take out? Horse pucky. Let's take out everything, and I hope I don't erase. Dog it. That's the one thing I haven't learned how to do on here. But of course, I haven't had any training, but hopefully one day I'll know how to erase the board without erasing the big stuff. Or maybe they'll schedule a training for faculty staff work day in 2050 maybe. Two of our sessions was helping the elderly and metabolism and weight gain. That was two of our sessions yesterday. But we got people with these projectors and boards in their rooms, and they can't even use them. Okay, so let's change this right here. Mark that out. Just get you another piece of paper and mark that out. And I want you, what is the probability of the marble falling on 0 or double 0? You still gonna bet $500. So I want y'all to work that. Take a minute and work that one. Where'd Miss Riddle go? She quit.
No.
She didn't quit. Hey.
Oh.
I was hoping she got discouraged and quit. Dadgum, I ate all my gummy worms. Life sucks. I took 2 bags of gummy worms with me yesterday, and I ate all of them.
I'd be stopped up.
Okay, that's a little bit TMI, thank you. I like gummy worms. That's one of my weaknesses. But I guess it's better than eating a Big Mac. Simple sugars, you can burn it off on the treadmill.
Let me see.
I see where AOC is saying that we need to get rid of planes and farting cows and jet planes and cars. Okay, nobody
Wait,
saw
we need to
that.
get rid of them?
Huh?
What, we need to get rid of them?
Yeah, we need to get rid of them in the next 10 years.
Oh, I'm not gonna have a job in 10 years then. I go.
I guess everybody will be driving buggies and Flintstone cars.
Go back
Can you
to
believe that somebody voted that person into Congress?
Not really.
And gotta get rid of cows too because they fart. Evidently, they ain't been around a lot of horses because horses are worse than cows. Dang old horses can't move without farting. Okay, I'll keep going with the math. Nobody's gonna say anything. Oh, I thought you said you were in talkative mood, Miss Riddle.
I mean, I am, but
You just don't want to talk about.
I don't want to talk
jets.
about math.
Okay. Well, I'm not talking about math. I was talking about idiotic ideas.
Well, you're talking about farting. I'm a girl. I'm not supposed to talk about farting.
Okay, well, I was talking about cows. I wasn't talking about people. I was talking about cows. Well, y'all want to talk about anything? That would be a hell to the no. Oh, well, I guess I will talk about math then. I give y'all the opportunity, but y'all don't want to talk, so. All right, so how many slots are these?
Two out of 38.
Okay, I'm gonna ask again. How many slots are 0 and 00?
2.
Thank you. 2 over what?
38.
So what is failure?
36 over 38.
Good job. This communication thing is really working.
I told you to make fun of me. I'm done talking.
What?
I was
What?
talking earlier, and you gave Alyssa the credit for it, and then I talk and you make fun of me, so now I'm just
I don't even know who said it.
Well, I guess
I'm
that's good.
sorry. I'm a piece of crap. I'm sorry. I didn't know who I was making fun of. I don't know. All I
No,
know
but
is I
then-
barely hear you. It's like walking up my door at my office and going like this. You walk up somebody's door. When you answer
No, but
me,
then earlier-
please.
Earlier
It's like when
she
I
gave
get-
an answer, and you were like, no one's going to talk but Miss Riddle. I gave you like 10, and you gave her credit for all of them. And my hand was over my mouth, so like it...
Well, I can't see because you got so much glare behind you. All I see is silhouettes. And y'all won't go over there and drop you won't do that for me. I mean, I asked y'all to do it in a polite way, and y'all just like, forget him. I'm not going to do that. Oh, that's much better. I can see what color shirt y'all are wearing. Wow. All I saw was silhouettes. All I saw was a head and shoulders. That's better. I can even see back to the back of the room. Thank you, Miss Riddle.
Mm-hmm.
Okay. Miss Morgan, I apologize. I suck. Okay, so here's my probability of 2. So we go over here and we erase this. And we put 2, which is 1 over what? 19? Somebody give me 1 over 19. What is that probability? 1 over 19.
.05.
0.05. Somebody tell me, is that much larger or much smaller than 0.47? I didn't hear. All I heard was a. It might be the microphone. The microphone may be cutting you off. I'll give you that much, okay? It's much smaller than 0.47. All right, now do B. Put the probability of failure over the probability of success. And what's going to be on top? 36 over 38, Hubert. That's right. And what's going to be over bottom?
2 over 38.
Thank you. I do not divide by a fraction, so I multiply by the reciprocal. The 38s will always go out, or those 2 will always go out. And that leaves 36 over what?
2.
Which is?
18.
18 to 1. So, somebody tell me what happens if I place a $100 bet on 0 or 00.
Ooh.
Well, 5 times 1 is 5. And then 500 times 8, that's going to be, 5,000 times, that'd be 5,000. 5,000 what? 400?
Is that right?
I don't know. Multiply 500 times 18. What do you get?
It's 9,000.
Okay, 9,000. What? Even?
Yes.
Good gosh, a while ago I just won $50. Why did I win 9,000?
Probability is a lot smaller.
Probability is a lot smaller. So when you go to Vegas and you play the nickel slot machines and you wonder why you don't win any money, it's because you're playing the nickel slot machines. You go over to the roulette table and pick one number or pick those 0 and 00 and you'll win a lot of money. But the problem is it has to what? That marble has to fall on that 0 or 00. So what do we know about probability and odds? Write it down because it's very important. Because some of y'all are going to explode if I don't hurry up and finish. If the probability is low, the odds are what? The odds are high. If the probability is low, the odds are going to be what?
High.
Okay. Now y'all can work on the first section of homework if you hadn't started on it. All right. Y'all have a good day, and I'll see y'all Friday. Hurry up and get out of the room before you self-combust.